Okay, an office supply company needs to hire temporary workers to get through the busy season. They have two agencies to choose from: Temporary Solutions and Tempo Temporary. A worker from Tempo Solutions can do 4 jobs per day, while a worker from Tempo Temporary can do 3 jobs per day. And the daily cost for the one worker is $110, and Tempo Solutions is $80 from Temporary. If the office supply company needs enough temporary workers to do at least 90 jobs per day, they must hire at least twice as many from Tempo Temporary as they hire from Tempo Solutions. How many workers should they minimize the cost? Okay, so the question is, how can you minimize cost? So we want to minimize cost. That's the goal. What is the minimum cost? How much do each of them cost? They cost $110 from Tempo and $80 from Solution. So I think I'm gonna call it S and T. I think that would work for me. I need something that's just different, and we'll start with Tempo. So I'll say Solutions plus Temporary, and Tempo Solutions, Tempo Temporary can do 3 jobs per day, and the daily cost for one worker is 110 from Tempo Solutions and $80 from Temporary. Okay. So we have Solutions and Temporary, $110 from Solutions, $80 from Temporary. We want to minimize that cost. Okay. What other boundaries do we have? We have a jobs boundary. 4 jobs per day, 3 jobs per day. We need at least 90 jobs. So we have a jobs boundary that we have to deal with. Okay, so jobs. Solutions is 4 per day. And temporary is 3 per day. And we need to do at least 90 a day. And it must hire at least twice as many from temporary than solutions. They must hire at least twice as many workers from temporary as they do from solutions. How many should they hire to minimize cost? Also, we know that we have to be in the first quadrant because you can't hire a negative amount of people. So I also know that solution and temporary have to be greater than or equal to 0. I can order a 0 amount of people to do a job, but I can't order a -1 amount of people to do a job. So we'd have to be in the first quadrant for that to work. So I think that's what we need to set it up. Okay, so I think I'm gonna have to graph. We have 2 variables, and our method is to find where on the graph we are to find the corner points. So where are we at to find those corner points? So for this jobs one, we are at S equals 22.5 is the intersection. And that is just 30. Okay. And this is like y equals 2x. So in that case, it's shooting right out of the origin. Okay. Let's see what we can find. I don't think I need to graph anything other than the first quadrant. And I have a line that shoots right out of the origin because it's like y equals 2x, which is kind of like y equals x, but it's a little bit faster. Okay, what about this one? So I'm gonna call this, let's see what I should call it. Looks like I should call this temporary solutions, tempo temporary. So I'm gonna do S and T as my X and Y. Okay, well, it looks like I can have a lot of freedom of how I graph it. So if this is 22.5 and this is 30, I only need to connect them. Now I need to see where I'm at. Where am I on this graph? So does 0, 0 work? 0 plus 0 is greater than or equal to 90. That's false. So we have to be going away from that line. Have to be going that way because 0, 0 doesn't work. It doesn't satisfy the equation. So we have to be going at least to the right of this slanted. And then the other one, these are the ones I hate because I can't plug my 0, 0 doesn't work anymore. So that's frustrating. So I just need to see what point would work. For instance, does this point work? Does 0, 30 work on this line? Does 0, 30, is that true or false? Is that true or false? And that will tell me which side of the line I'm at. So if I plug in 30 is greater than 0, that's true. If I plug in 22.5 times 2 is less than 0, that's false. So I have to be on this side of the line. That would be the only one that satisfies it. So now I know my direction. Now I can find my corner points. Are there any questions, comments, complaints about how I found the region? Does not hurt my feelings if you want me to go over it again. Okay. Are there any questions? So I think there's a corner point here. I think there's a corner point there. And I think there's only 2 for this problem. I only see 2 corner points. Okie dokie. Let's see where this is. Where is that located? That's located when the 2 lines intersect. So we have t equals 2s, and we have 4s plus 3t equals 90. And we want to see where do those intersect. T equals 2s, so I would say substitution's the way to go. So we can substitute this, so that's 4s plus 3 times 2s equals 90. And that's going to be 6s plus 4s, which would be 10s. That seems to occur when solutions equals 9. And what does temporary equal? Double that. So it seems like that would be twice as much since it's 2 times. So I think that would be 18. So I think that occurs at 9:18. The other point is at 0:30. So we need to test those two corner points and see which one gives us the minimum cost. Equation is 110s plus 80t, and we should plug in 0:30 and see what we get. Oops. So that goes to 0. It's just 8 times 3, which is 24 with 2 zeros on it. Okay. And then the other point is 9:18. And that would be 110 times 9 plus 80 times 18. Okay. 2,430. And that would not be the minimum. That's larger. So this is the minimum. And that occurred $2,400. And we didn't get anybody from Solutions. We went all temporary. They had the better rates. And I claim there is no max. You could spend infinite amount of money to get an infinite amount of jobs completed, but I think there's only one there. Any questions? So I don't think there is a max for this. Only a minute. I could just keep spending money. Okay. Keep spending money to keep getting jobs done. But I think there's only a minimum. And it's not the minimum on the graph. It's the minimum of the objective function. And again, all of our problems in this course are two variables, but you don't have to have just two variables. If you have three variables or more, we need a more sophisticated system, which is called simplex method, which we don't study in this class. But strangely, the summer finite online people, they do study simplex method, because generally you would want a computer to do it. It's an algorithm, but these you can, they study these too. Then they do a hard. Are there any questions